Today we will be talking about GraphQL on Springboot with Alberto, and this was just a pet project. I wanted to explore a bit Springboot, how GraphQL make it more complicated or simplified was my question, and Alberto helped me to make it proper applications. So we decided to share what we have experienced and a bit kind of our exploration on the space. I'm Ebru to explore the graph space more. And Alberto, do you want to give intro?
Yeah. I'm Alberto. I'm a senior consultant. I'm really trying to get more involved into the cloud space and cloud data.
What we will be going through is definition of GraphQL. What's GraphQL? The API, the operations. It has a specific schema. We will walk through the schema. And Alberto will be explaining the resolvers, how the data fetching and the loader works, as well as the query, mutation, and maybe extra kind of client operations. So GraphQL is a query language for an API. It's not building a new API for your existing applications, but we'll make it server-side definition, and the client side will just use the same definition. So they can exchange without resolving, transforming on top of the existing API given. So it's giving an ease to developers, really, to applications. It can be deployed within an IDE. It's called GraphQL. It has built-in UI that you can run your test, and actually in memory it does create your mutations and the queries, which we'll be talking. All the endpoints are available. It's an alternative to REST. GPRC. REST was supposed to be offering the hypermedia controls, HTOs. So if you want to describe what you want to say to the internet, like if I want to have show me how to submit my mortgage application or give me this information, it was explicitly described. If your API is not supposed to be doing that, it doesn't have to be defining what it should be doing, then GraphQL may be the solution for it. It will simplify the request and take off the load that you had to think about. So if you think you weren't doing REST anyway, GraphQL is another door you can put all your APIs and endpoints to be used. There are some type definitions we will go through. The default, one of the fundamental types is the query, where you can say, who am I? As the user definition, you can pass any parameters or fields, and you have to define what the type is. We will go through the details of how the schema definition is done. So I will leave this just an example, but it's very simple to use. As a history, first in 2008, Netflix had something called Falcor, but it didn't take off. That wasn't very popular. And when Facebook developed GraphQL in 2012, it did have some attraction. And in 2015, they open sourced it as part of the GraphQL Foundation. And now it's part of the Linux Foundation. In 2018, they had the GraphQL schema definition language agreed and published. And right now it does support multiple languages: JavaScript, Python, Ruby, Java, Go, and much more. Why it has a name on the graph? That's a bit confusing. Are we really doing graph implementation? The motivation even looks similar, because you are exploring an API. An API has lots of dependencies, and graph is a way of defining and exploring it. So this interface doesn't allow you to traverse back to the parent or navigate through the links, relationships between the endpoints. So it's not a proper graph implementation. However, Netflix is working on something called GraphQL Federation. Also, Apollo has similar. They have Apollo Server Federation, which kind of works from the graph mindset, where you can import your graph definition and you can navigate through the endpoints. So it does help you to navigate through if you want to have the recommended videos, you can go through the video and it went back. How it does is it uses a gateway, and that client hitting that gateway can navigate through multiple endpoints for the movies, productions, or talents, and then it can go back and ask about the schema registry and come back, so you have the full resolution of your endpoints. So why it's kind of helping us as an API? There is no transformation, as I said. It's you get what you see. There is no fetching. There is no under fetching or over fetching. There is no waiting for the API modifications. It's instant, very fast. There is no long chain of API calls. You do define what you want to get, and it's one-to-one relationship. So there is no external dependencies. No long debates on API design. It's under version control, then that one file will define your endpoints. No API proxy boilerplate. No complications yet, maybe, but the motivation is to make it simple. And there is no documentation worries. It's self-documented. No discovery issues. Again, it's self-discovery. It's just one file, which I will show the kind of the configuration or definition of the schema. So what can we do? We can do 3 types of operations. The first one is query. It's a read-only fetch. You're just getting the information from that type or the definition of the components. You can do mutations. This is the write operation if you want to modify any file, add new items, or change the properties. And the last one is a subscription. It is to be able to request multiple times within the source event. So you don't have to do get me the book number 1, get me the book number 2. So you can batch and subscribe to the event and wait for to retrieve the rest. How do we design the schema? Alberto will go through them.
So when you define the schema for GraphQL, everything you define are types. Types then can have multiple fields, and in this example we only have strings, but the fields can reference other type in the same schema. For example, the files here is of type list of strings, and the brackets say that this is actually a list of strings. Next slide, please. Yeah, so the resolvers are basically some methods or functions that resolve the value for each field in the schema. So each of the fields is assigned a resolver. And yeah, so basically they can return different types, the usual string, numbers, boolean, and object types as well. As I said before, so the object type has to be referenced in the same schema as another type. And yeah, when a scalar value is returned, then the execution completes. When an object returns that, the execution continues to get the next child field. The resolvers can be also synchronous, and they can also resolve values from database, cache, and constants and REST APIs. Yeah, so basically, as I said before, each field has a data feature, and so basically in this example we have the query, which is a different special type of type, which is basically the type that exposes the operations that you can perform on the other types in the schema. And for example, for these queries, they can have complex type of fetchers. For example, fetchers that need to retrieve values from a database, from a cache, or from some other type of backend. While the simple types, like products in this example, references basically a Java POJO object, which means that each of the fetcher is basically referencing the getter from that object to retrieve the value of the type. Next, please. Yeah. So yeah, we have these are the special types of types in the schema for GraphQL. As Ebru described before, the query is where you can perform get operations on the types. For example, here we have bucket list and bucket by name, and mutation is when you want to perform operations like post, like when you want to add new values into the database, for example.
Yeah, if I show the GraphQL, that I will walk through kind of how we can define. This was our basic application. Let me start. It's already up and running, so I'll start from the endpoint. The endpoint is defined in my configuration, but I said, let me get the localhost GraphQL endpoint. This is by default, it has the configuration within the solution. It comes with this default setting, just an explanation like a README, and the rest, and possibly those parts as well, kind of are helpful to understand how you prettify, how you run the history of previous queries. And I can go back to the old one. The definition is simple. You just, for the curly brackets, who doesn't love curly brackets, you start with the field, which type you want to query, and then it will have an argument, a bit JSON-like format with a value, and also you can define the subfields. In our example, we kind of tried to do an AWS structure where models, we had an account, AWS account. Each AWS account has VPCs in it. Actually, in every AWS, step back, we have regions, kind of an account for a specific account and a region. You may have a VPC and a bucket. So these are kind of interconnected. And I should be able to query, given my AWS configuration, which buckets I have, and I can write operations to that endpoint list or change them. So we defined the repos. Alberto can explain them properly. I have the previous version of the code. The most important part is the resolver and the mutation, which will tell me what I can do. So this file, under resources, we have the models.graphqls. This is the file, just one file, defines my models. Each account, I say there will be an ID, it's a string, and it can't be null. The exclamation mark tells it. And similar with the field names for the VPC, similar bucket. And the more important part is this type and mutation. So that's the heart of it. Tells that if I want to query what I can query the account list, or I can by ID get the parameter and return me an account. I can get the region list. These are all my definitions, apparently. VPCs by ID, VPCs by account name, or get me the bucket list. And under the notation, we have simple add account. We provide a new name, and it will create a new account for me on AWS. This is how it's interpreted, kind of when I run. I do run. Actually, there's a helper. I can cheat, which is awesome. On the query and mutation, it does give me the documentation explorer. So even if I have no idea what this endpoint is doing, I can go to query and see the same GraphQL file definitions. And with the account list, it will tell me that, okay, it does return those values that I can retrieve, or VPC by ID is going to require a string ID. So if I want to say query bucket list, I have a bucket list called name, and I can verify I'm not cheating. Can I? It's not going to ask me to log in back. Yeah, it's given the test my bucket demo is one bucket inside it. So if I go back, if I say file, it gives me an int. It's a bit wrong, maybe it's my definition, but that's my bucket demo 2021 is the bucket I have under as a file. If I create another one, demo 2021, OpenCredo, and go back. I'm not sure if I need to. I see, I didn't hard coded those values, so it should get me the names and the files. Maybe it's picking the first one. It was good because test. I may want to stop and restart. I shouldn't need to do. Hey. It has, I guess it's the AWS sync time that it may take time. I don't think I need to refresh, reload, or reboot the application, but now the one I added, demo 2021, OpenCredo has the buckets rather than the files, which is apparently a mistake, but this was a simple kind of application to show what I can do. I can also account. It has nice kind of helping the UI, give me the account list. It has some IDs, and it does help me if there are any field properties that I can type. It just has the ID, and so it's such a nice kind of UI that I can navigate, see, and explore, and it's single source of truth. Doesn't happen anything. And similarly, if I want to say mutate mutation add account, and I need to cheat here for the it does require name. That's my test account. It did give an ID, and if I query account list with name, ID, it created the test account 1, 2, 3, 4, an ID inside it. So I can do mutations, I can do queries with basic implementation. Any questions? Or any comments, something you liked it, you didn't like it, or you have already played with it, so you already know what's going on?
I put it in a box on an architecture diagram once. Or we'll use GraphQL and wave my hands over it once, but I've never played with it. I think we used it to, we were planning to use it, but actually, what's quite nice about it is that actually you could even call other REST endpoints underneath as well. So you could use it as more like an adapter pattern, so you can kind of strangle out some old REST endpoints and kind of present a new interface and then kind of get rid of the old endpoints and stuff, which was our plan to use it. But it's cool. I like this IDE though. That's quite handy.
Yeah, it's a strangler pattern. It's very commonly used, or strangler peak now.
Yeah, I think it has a more friendly name now actually. But I like this IDE though. This is kind of cool.
Yeah, with the history and everything. We are not showing today, but Apollo server has a nice one as well, similar to doing multiple queries, but this is built-in. Just a bit on the configuration, I had to kind of tell where the GraphQL server is running, kind of which endpoint, and this is the GraphQL. It's, as you would expect, just a dependency on the Springboot. It was very simple to implement. With the version, with the AWS, kind of we had to plug in the configuration where the static file and the AWS configuration file profile is. Usually, if I show kind of AWS, when you install the SDK, it does put some, you don't see those ones, they will be changed, the secret IDs and the key IDs, but it does pick which profile name you want to access to, kind of region by default. There you can change later on. Kind of was nice. Also, we could put different endpoints, port numbers on the application properties. That is kind of the basic implementation. Alberto, do you want to go through the Lombok and how your code looks like a bit? Go through the code base, because you have the advanced version of this. I have the simple version. You are on mute.
Yeah, I can show some of the updates that I have implemented. Yeah, so as Ebru was saying, this is a Springboot application. So yeah, this is the main class where we basically have a main method that starts up the application and then loads the repo as startup by using the command line runner. We have the configurations where we define the mutation and query beans, which are then used for the queries on the GraphQL schema. And then we have the bucket repo, same for the other ones as well. We have where we call the AWS and load the information from the different buckets in the region, in a default region. Then I created some of the loaders that basically at startup they get the value from the configuration. This is just Spring Boot, and this is a component from Spring Boot as well. So yeah, here basically iterates over the buckets and then loads the files from each bucket. And the service is where basically we have we call the loaders from each of the different types. She described the Gradle file where we have all the dependencies. Basically it's just a Spring Boot application which uses the GraphQL libraries as well. Lombok is just a utility in Java that allows you to avoid writing all the getter and setters equals hash code to string just by using the annotations on the top of the classes. That's about it.
Okay. As for the next iteration, possibly we want to explore more GraphQL Federation, kind of how this works, because apparently Netflix, Apollo Server, and other applications teams are trying to create that gateway that we are still not sure how it will play with creating that graph network and exploring different APIs, possibly hidden APIs, as James suggested, kind of under the hood that we can call. And Apollo Server looks very, very promising. Also, last week there was dgraph, which is, I don't know if anyone heard of it. They are trying to implement GraphQL on top of a graph database, so it looks really kind of a native graph. Last week they had full day conference, and from FactSet to other companies they implemented, and apparently they are using in production. So it may be gaining attraction in near future. More and more you may be hearing. How successful it will be, how much of the REST API will be converted to GraphQL is another question, but watch the space. Thank you.